All right, today we're going to talk about inscribed angles. We're still looking at circles, and now we're looking at an inscribed angle, which is inside of your circle. An inscribed angle is an angle with its vertex on the circle. So you can see the vertex is on the circle with two sides that are chords. So you've got AB and BC are chords. An intercepted arc is an arc that lies between the endpoints of the inscribed angle. So if we have inscribed angle ABC, our intercepted arc would be AC. Okay? The degree of an inscribed angle is equal to half the measure of its intercepted arc. So you can see the formula here. The measure of angle ABC equals half the measure of arc AC. All right, so in intercepting a diameter. All right, for the next one, an inscribed angle intercepts a diameter, then it's a right angle. Okay, so we've got an arc here, and this line here intercepts the diameter. The diameter goes from BC. So since this intercepts that, it forms a right angle. So this angle here would be a right angle, which means it's equal to 90 degrees. And that's something you will need for some of the problems that we're working later. So that's called an intercepting a diameter. All right, the last thing we're going to look at before we do some problems is overlapping arcs. If two inscribed angles intercept the same arc, then the angles are congruent. That means they're equal. So if we look here, we're going to say that the measure of ABD, so we've got ABD, and that's going to be equal to ACD. All right, that means these two angles are congruent. So this would have an angle sign here, and that means this angle would be congruent to that angle. All right, let's look at some examples. All right, the directions say find each angle and arc measure. For number 1, you're given the arc, so you know that the measure of the angle is half of the arc measure. So if this number is 62, we do half of that and get 31. All right, get my pen here to work. All right, number 2. This time they give us the angle. So we're given the angle, which means that is half of the arc measure. So now we have to double it. So 2 times 113 is 226. So again, we're just using the equation given above. All right, number 3. This is a diameter. And so that creates a 90-degree angle here. And it asks for the measure of PQR. So we know that that angle is 90 degrees. All right, looking at number 4, it has a couple more steps that you have to do. First, we know that the angle is half of the arc measure. So if we take 47 and double that, we get 94. And then we look at this and it says, what is the measure of arc BC? So it wants this arc measure here. Well, how do we find that? Well, we can find that by saying either this plus this equals 180, or we know that this is the diameter, so we know that this semicircle is also 180. So you can just do 180 minus 94 and get 86, or you can do 360 minus 180 minus 94. All right, number 5 gives us the 2 smaller arcs, and they want us to know what is the measure of JKL. So we're looking for this angle measure. Well, we don't know the angle measure, but if we can find this arc measure, then we can find this angle measure. Again, we know that the whole circle is 360 degrees. So if we do 360 minus 65 minus 53, that gives us 242 degrees here. So all three of those together equal 360. And we know that this angle is half of the arc measure. So the angle is half of 142, so that would be 121 degrees. All right, number 6, we're given 64 degrees, we're given 139 degrees, and we're given 75 degrees. So again, we know the whole circle equals 360, so we can take these three numbers and subtract from 360 and get 82 degrees here. And then it says, what is the measure of RST? So RST is going to be half of that 82, which is 41 degrees. And then it says, what is the measure of RUT? RUT is going to be still that half of 82, or 41 degrees. All right, number 7 says solve for x. So 8x minus 9 is going to be this angle here, and we know that's our inscribed angle, and we know that's half of 158, so we know that this angle equals 79 degrees. Well, if 8x minus 9 equals 79 degrees, all we have to do is solve for x. So we're going to solve by x by adding 9. Divide by 8, and x equals 11. So this time it just said solve for x. All right, number 8 says solve for x as well. All right, so we're given the inscribed angle, which is 67, and we know the angle equals half the arc measure. So the arc measure is going to be 4x plus 58. And then we can solve for there. So we go 67. Half of 4 is 2, so 2x. Half of 58 is 29. Then I'm going to subtract 29 from both sides. And 2x equals 38. Divide by 2, x is equal to 19. All right, you can plug that in and see if that works for your equation. All right, number 9 also says solve for x. When we look at this, we have a diameter, and we have this intercepting the diameter. So we know that this is 90 degrees. And so we can say 13x minus 1 equals 90, and we can solve for x. So add 1 to both sides. So we've got 91 equals 13x. Divide by 13, and x equals 7. Again, that's just coming from the very beginning where we looked at those definitions. Because that's a diameter, we know that's equal to 90 degrees. And since it gives us this, that has to be equal to 90, and you can solve. All right, number 10. All right, we are given 78 degrees for this arc measure. We're given 114 degrees for this. And we need to find what x is. So first I'm going to say all right, need to look at this one for a second, but what we are given is this arc measure and in one angle here, and then this information here. So I can use this 78 as this inscribed angle is half of 78. So I'm going to look and I'm going to say half of 78 is 39. So this angle here is 39 degrees. Now I also know that a triangle has to equal 180 degrees. So if I do 180 minus 114 and minus 39, that's going to give me this angle here. And I know that this angle is 27 degrees. All right, so you have to know facts about triangles as well as circles for this one. All right, so we've got 7x plus 6. And that's going to equal the 27 degrees that we just found that angle to be. And then solve for x. So subtract 6. 7x equals 21. Or x equals 3. All right, let's look at example 11. So we are given this arc measure and this arc measure. You can see there's 3 arcs in this circle, so we can find the third one by taking 360 minus 162 and minus 92. And we do that and we're going to get that this arc measure is 106. So 106. And then we're going to say, what do we need to do to find x? So we know that that angle is related to, this arc measure is related to this angle. So this angle is going to be half of 106, which is 53. And so we can say 7x minus 10 is equal to 53. X equals 9. All right, let's look at number 12. All right, so since we're given the inscribed angle is 67, we know the arc is twice that. So twice 67 is 134. And we know that this plus this plus this equals 360 degrees. So we can do 360 minus 120 minus 134. And we know that this one is equal to 106. So we can say 5x plus 21 equals 106. And then I'm going to subtract 21 from both sides. And x equals 17.